Happy summertime. As I get my summertime ducks in a row for the next 2 weeks, I'm going to be reposting one of my favorite podcasts that remind me of summertime. It is the podcast about the Flip Flap roller coaster, and it's quite a ride. I will be sharing a new story with you in 2 weeks. Until next time, carpe diem. The history of math is our intellectual foundation for understanding science. Science. Beautiful, remarkable, awe-inspiring science. It's the creative foundation for our ineffable future. Hi, I'm Gabrielle Burchak, and this is my podcast, Math, Science, History. In the year 415, the infamous philosopher and mathematician Hypatia of Alexandria, Egypt, was savagely murdered by church monks. This murder shocked the Roman community and its government leaders. Hypatia was known far and wide as a respected philosopher, mathematician, government advisor, and a professor. Hypatia, The Sum of Her Life, is a book that I wrote that looks not just at the circumstances surrounding her death, but also at the sum of her entire life. I weave in the details of her education, disciples, Neoplatonic philosophies, female contemporaries, and the many mathematics that she wrote and taught about. There is truly more to Hypatia's life than her death. Hypatia, The Sum of Her Life, written by me, Gabrielle Burchak, is now on sale on Amazon. Buy your copy today. The day was January 20th, and the year was 1885. The inventor was Lamarcus Thompson of Coney Island, New York, and the patent number was 332762. It was the first United States patent for a roller coaster. This particular roller coaster would be built on Coney Island, and it was called the Gravity Pleasure Switchback Railway. It sounds kind of not safe for work, but I promise you this is a clean podcast. Originally, passengers would pay 5 cents per ticket to ride a cart down a 600-foot mini railway that really only went about 6 miles per hour. It was quaint. The Gravity Pleasure Switchback Railway stayed in operation until 1933, and it was a pretty good run. Ultimately, though, the roller coaster was sold for scrap in 1937. The next great Coney Island roller coaster was called the Flip Flap Railway. It was the summer of 1895, and it was the first roller coaster with a loop. However, many people suffered whiplash and neck injuries and even worse, ejection. They were actually ejected from the roller coaster, and so the Great Flip Flap actually just became a flop. What they didn't understand then was the effect of gravity forces on the human body. Technically, our bodies can only handle a force of 5 Gs. However, the flip-flap made their thrill seekers endure 12 Gs on the body. This was not good. 12 Gs actually causes gravity-induced loss of consciousness, or what pilots refer to as G-lock. There's actually a really funny video created by Brian D. Avery on TED-Ed about how high G-forces affect your body, and I highly recommend it. I'm going to provide a link to that video on my website at mathsciencehistory.com. Basically, what our early roller coaster engineers did not understand is that our bodies are accelerometers. We feel acceleration. This is the key factor to what we feel when we are in a roller coaster, because for the most part, the roller coaster is propelled completely by the power of gravity. We feel the roller coaster obtain potential energy while we undergo anticipation as we slowly climb up the roller coaster from the lift hill. Or we suddenly feel a burst of energy as we are rapidly propelled forward from a hydraulic launch system. But no matter how you get to the top of the first hill or mountain, the best part about the roller coaster is the feel of gravity as the potential energy turns into a glorious kinetic energy, and you go into a state that feels like a free fall. So our bodies are either being pushed into our seat on the climb, that's the ascent, and that's potential energy, or our bodies are floating above the seat on a small scale as we feel kinetic energy on the descent down the hill. You see, normally we feel gravity on our body as we stand or sit. That force that we are used to on a daily basis is just 1G, one gravity force. But when we're falling from a high point on a roller coaster, there's no force pushing up on us, and we are free falling at 9.8 meters per second squared, which is the force of gravity. And again, since our bodies are accelerometers, we feel this. And it's awesome. We are accelerating towards the Earth at 9.8 meters per second squared, and that is gravity showing us a fun time. Also, inclines increase the G-force, so the steeper the hill going down, the greater the G-force. Now, for the flip-flap. What went wrong? Well, for all looping roller coasters, as a roller coaster is going into a loop, the speed at which we move provides us the inertial velocity to get to the top of the loop and then back down again. The roller coasters use centripetal acceleration to keep the cart moving on the track. If you have been in a looping roller coaster, which I highly recommend, you will feel the heaviest at the bottom and the lightest at the top. What we actually feel acting on our body is the normal force, which is one of two forces acting on our body. The normal force means the force that sits perpendicular to the surface that you're sitting on. The other force is gravity. As a result, as the velocity moves us forward, the net force on our bodies keeps constantly changing because the normal force is changing. If you need a visual, I have images that I've provided on my website at mathsciencehistory.com. It can show you how these forces act on our body. So, as the coaster moves to the top of the loop, passengers should feel a sense of weightlessness. Again, that's the normal force that we feel, and the normal force is minimal. But for the flip-flap, once that coaster started to go back down, gravity began to pull on it. The flip-flap was a perfect circle, so the loop's curvature was constant. Looking at the images that are on my website, you'll see that the net force points inward. So once the coaster reached the bottom of the track, because the force of gravity points outward, that doesn't count in determining the force of the normal force. And because the net force points inward, the normal force must be much bigger than the force of gravity. That normal force was so much stronger than the force of gravity, and it was exerted on the passenger sitting on the wooden cart on the flip-flap. At that instant, the flip-flap passengers endured 12 Gs on the base of their spines in a wooden cart. Also on my website, I include a really great video created by the Art of Engineering that explains the force of gravity entering and exiting the loop. It's a great video that perfectly explains the math and physics behind the circular loop. And it also explains how the clothoid teardrop shape that we now use creates a gradual change in curvature and reduces the maximum force at the bottom of the loop. Today, the roller coaster is controlled and not as crazy as the original roller coasters of the 19th century. We now have standards in place that are set forth by the American Society for Testing and Materials that prevent G-force exposure limits. These G-force limits incorporate facets of physics and design. Also, thanks to 3D modeling and computer analysis, we can now design some amazing roller coasters that can be tested on the computer in order to ensure your safety. So, if you're on a roller coaster that makes you feel like you want to die, don't worry. We've got brains on the job making sure you're just fine. If you're interested in learning more about the physics of roller coasters, I have a couple of videos listed on my website that provide the math and the physics behind the circular loop that was the flip-flap roller coaster. But just in case you didn't know where I virtually live, I'm at mathsciencehistory.com. Please come by and visit me. And until next week, carpe diem. I'm Gabrielle Birchak. This podcast has been brought to you by caffeine. Delicious, wonderful nectar of the gods caffeine. Coffee, tea, coffee candy, you name it. I love it. Thank you for listening to Math Science History. If you are interested in reading more about the history of math and science, please come visit me at mathsciencehistory.com. And while you are there, if you like what you're listening to, please feel free to click on that coffee button and buy me a cup of coffee. Until next week, carpe diem.